All righty, good evening, everyone. This is meteorologist Timmy Albertson. For tonight's weather chat with Timmy, we're not actually going to be taking a look at the current weather ongoing, albeit, it did snow up here where I live today. We got about 2.5 inches of snow, and it's still on the ground. Also, I got to get changed into my Halloween costume to get ready to hand out candy. But one thing I love to do around Halloween is talk about one of my favorite weather events. I'm talking about the perfect storm. That's right, folks, the perfect storm. As described in the bestseller book, The Perfect Storm by Sebastian Junger. And it was eventually turned into a movie that is one of my favorite weather movies, The Perfect Storm. This thing has gotten a lot of use growing up. This movie came out when I was about 7 years old, and it's actually directed by a guy named Wolfgang Peterson, who just recently passed away. And he also directed one of my all-time favorite war movies, Das Boot. I have the complete extended original cut. Fantastic movie. I think between that and Brescia Post, probably my two favorite war movies. But let's go ahead and talk about Wolfgang Peterson's movie here, The Perfect Storm. It's a fantastic movie, and I will say a lot of meteorologists talk about Twister and how that got them interested in weather. I do remember Twister. I don't remember exactly what it was that got me obsessed with weather, but I do know that I had watched Twister probably about a million times by the time the movie The Perfect Storm came out. And The Perfect Storm, at least for me, is is kind of an important weather movie for me, because this is the movie that, even though I was already obsessed with weather by the time this movie came out, this movie really got me interested in large scale weather systems, whereas Twister focused, on smaller type of scale weather systems like tornado outbreaks. The Perfect Storm deals with a very large area of low pressure that didn't just affect New England, it also affected the upper Midwest, and we're going to talk a little bit about that as well. So if you've never seen the movie, I like it. I personally think that the CGI in The Perfect Storm still holds up even to this day, even though this movie came out in the year 2000. Got James Horner does the music for this movie. James Horner is my favorite movie composer. He did Titanic, Apollo 13, which is another one of my favorite movies. The Perfect Storm, obviously. He did Avatar. I think he did Braveheart. He's fantastic, and I think this is one of his best scores. Is this movie? So we're going to talk a little bit about what the movie The Perfect Storm is based off of. Well, and actually what it's about, and that is the Halloween nor'easter of 1991. Again, I won't give away much about the movie. The movie, weather-wise, is pretty accurate on a lot of things. One thing it does Hollywood a little bit is it kind of focuses a lot on Hurricane Grace, which is one of the features of The Perfect Storm, and it mentions that Hurricane Grace at one point. It's a very brief moment in the movie, but they mentioned that Hurricane Grace is a Category 5 hurricane. In reality, Grace was never a Category 5. She was only a Category 2 at her height, and by the time this all began, she was actually a little bit weaker than that. But let's go ahead and talk a little bit here about the setup of The Perfect Storm. And again, as I mentioned, folks, there are two parts to this storm. One of them being the New England portion, which is what The Perfect Storm was based off of, especially with the Andrea Gale out in North Atlantic. But the other part of the storm was actually Minnesota. And so The Perfect Storm was not just one storm, it was actually two. And so we're going to take a little bit here of a look at the weather map. Now, folks, this is 1991 here. So unfortunately, the weather map isn't going to be as in high def clarity as some of the weather maps that we have shown before. But this is kind of how the weather map looked. A lot of information going on here. So let's kind of zoom in a little bit here. This was by Monday morning, October 28th, 1991. And here's what was going on here. If we kind of zoom in over a little bit here across the East Atlantic, that's Hurricane Grace. All right. Hurricane Grace was just moseying its way along, doing what hurricanes do, and that is moseying their way along. At the same time, though, we have this cold front that was beginning to work its way off the east coast of the United States. And eventually what would happen is that Hurricane Grace would begin to interact with this cold front. And the cold front would actually, the whole parent system associated with that cold front begins to feed off Hurricane Grace. Now, we've talked about before, we talk about low pressure development, we want a temperature contrast, and we also like, low pressures love to lift warm, moist air. That's what makes hurricanes very strong. And again, Hurricane Grace itself was an ample supply of warm, moist air for this low pressure system. But what you don't see on this immediate weather map here is one of the biggest culprits for the perfect storm, at least at the surface, an area of high pressure. And normally we don't talk about high pressures being kind of the culprit here, but this was an unusually strong high pressure across Quebec. Very strong high pressure. And as we've talked about before, high pressures are the dominant thing. Okay, low pressures don't move highs. Highs move on their own. They go where they want to go. And in this case, this was a particularly strong high pressure, at least about 1044 millibars. Okay, so we've talked about the average sea level pressure before is about 1013 millibars. So 1044 is a pretty strong high pressure, and it was hanging out there across Quebec. This was a problem for a multitude of reasons. Well, not a problem, I guess, but this was a problem if you were low pressure because you're not going to move that thing. So we have this cold front that's beginning to work its way off the Atlantic coast. There is a little bit of an area of low pressure with it there, but this high pressure is not going to move. So let's fast forward to the following day. The high pressure moves further into eastern Quebec. That cold front becomes entangled with Hurricane Grace. And what begins to happen is Hurricane Grace begins to basically dissipate as a tropical system. Again, most tropical systems will meet their end in one of two ways. They either run into a cold front or they just taper off in, over land. In this case, there we go. And take a look here. This isn't even the height of the storm, but take a look here already at what's happening. You got this area of low pressure right here. Okay, this is kind of the remnants a little bit. You can see Hurricane Grace down here getting absorbed into this overall area of low pressure. And you have this very strong high pressure across eastern Quebec. Take a look here at the pressure gradient that was off the east coast across Nova Scotia. We're talking winds easily sustained around 50 miles an hour. And winds are often faster over water because there's not as much friction. Land creates much more friction than the ocean water does. So winds obviously traveling pretty fast, and they're coming straight out of the northeast here off of Newfoundland, heading down into Nova Scotia. So already we're seeing very windy conditions, very high waves, and this low pressure is not done. As a matter of fact, this low pressure wanted to move northwards, but the presence of that high pressure made that very difficult for this low pressure system. So this low pressure system began to do something which is a little bit unusual when we talk about nor'easters. Now, normally when we talk about nor'easters, we talk about them in the wintertime when they produce a lot of snow across New England. The perfect storm was basically a nor'easter, but it was almost an opposite nor'easter in how it moved. Let's take a little bit of a look here at the track. We'll go ahead and flip up the image here, and this is the track of what it did. It started off the coast of Newfoundland there on your right, and because that high pressure was in the way, that low had no other direction to go except backwards, relatively speaking. It went towards the southeast, and then it turned and went towards the west. So you can see how over the next couple of days, the center of the system is kind of moving backwards and hanging right off the New England coastline. And again, if you also are familiar with this area, there is a decent temperature contrast with the ocean temperatures around this area, with the colder waters of the North Atlantic interacting with the Gulf Stream. So this is, and generally kind of a hot spot, especially in the fall and winter time for, some low pressures to develop and move pretty nicely. So now we have this large system that is, lost kind of its tropical characteristics, but it's got a lot of moisture to work with. It's got some warm water temperatures, and this thing exploded. And when I say exploded, I mean it intensified pretty well. So let's go ahead here, folks, and take a look back here on our weather map. So this is going into Tuesday during the morning. Let's go ahead and fast forward it to the 30th of October. Take a look there. You can see how it actually kind of retrograded itself backwards. We had that high pressure still that's just hanging out. You know what? That high pressure didn't feel like moving. All right. So it just kind of hung out there. And this, again, really tightened that pressure gradient. Now, if we actually back this up a few surface chart images, we could see that the system really reached its peak intensity late in the night on the 29th and into early October 30th here. Take a look at some of the pressure values with this. This low pressure center, about 984 millibars. And we got a high pressure not too far away, around 1040 millibars. That is a heck of a gradient. And folks, this might look far away. If you've ever traveled this distance, yeah, it's a pretty long drive. But in weather, this is actually pretty close to each other. And look at that pressure gradient that you see right here coming off. These were some very strong hurricane force winds effectively across this area. Now, the Andrea Gale, again, which is what is the story based on, that's the boat right here in this picture. The Andrea Gale by this point was en route back to New England. And it was right in this area, okay? This is an area that easily saw waves over 30 feet. There was one buoy observation, and that's what I forgot to get ready, was to pull up the exact details about that. But there's one buoy observation, though I believe it's still somewhat disputed, of a 100-foot wave, okay, out here in the waters here. Now, for those of you who don't know, this is actually kind of shallower waters right here off the Canadian coastline. So it's not necessarily the deep waters like you'd see further out into the Atlantic. So that probably had, at least I'm not, when it comes to ocean physics, it's not my realm of expertise. But regardless of the fact, that is a pretty strong system. So this dude just kept on intensifying. And like we see here, take a look, see this little low, not little low, this big low right here. Watch how as we go over the next couple of scans, you can see it retrograding backwards. All right, it's kind of moving an opposite direction of what we would normally see. And that's because of this high pressure being in the way. So now you got the New England coastline, which is just being battered with pretty decent waves and pretty decent winds. Now, it should be noted that as strong as this system was, its effects inland, not necessarily, certainly some areas, especially right along the coast, saw some very decent impacts for it. But when we talk about a system like this, you'd expect the impacts to go further inland. Not necessarily the case. This was, again, mainly confined to the coastal areas here of New England and the Canadian Maritimes. So that low spins around. And like in weather, all things do begin to kind of weaken. And by the time we get towards the 31st, you can see that low has now moved back towards the mid-Atlantic coastline, but it's noticeably weaker by that point. Here's where the perfect storm gets even more interesting, folks. This was not the end of it. As weird as this system was, it ended even weirdlier because it transitioned back into a hurricane. That's right. So it went from being a hurricane that got absorbed into a low pressure system, this extratropical low hanging off the New England coastline over the course of a few days, and then it begins to regain tropical characteristics. Those thunderstorms organize. There's now, it's over the warm waters off the off the East Coast, and it begins to transition back into an actual hurricane, eventually attaining Category 1 hurricane status by the time we got into the following day. So by the time we get towards, the first day of November, we now have this hurricane, albeit not a very strong one, but it's still hanging out there in this mess. And then it decides that it wants to track its way into Nova Scotia, and it did so, albeit in a weakened state by the time it did reach there. That is the few-day cycle of the perfect storm. Now, interesting side fact about the hurricane portion of this, as mentioned, Hurricane Grace got absorbed into it. But what about this hurricane? What was its name given? It didn't have a name. Very weird. Forecasters were concerned that if they named it, it would, because it wasn't necessarily expected to do this part, the transition back into a tropical system part. By this point, the movie plot is over. But, by this point, we kind of have this hurricane, but the Weather Service didn't really want to confuse it very much to the public because they just had a hurricane. Now it's not a hurricane. Now it's back to a hurricane, but it's got to be named because it's not the same hurricane that was Hurricane Grace. So it actually didn't get a name. It's known as the unnamed hurricane, which, again, many hurricanes throughout weather history have been that way. But, 1991, we were already naming hurricanes on a pretty regular basis. However, this one did not get a name, and it still does not have a name to this day. It's often known as the unnamed hurricane, or the Halloween hurricane, or just overall, it's just associated with the perfect storm, the 1991 perfect storm. All right, that was the Atlantic. Now let's back up. Let's back it up here about 36 hours or so, and we're going to talk about the other part of this storm, and that is going to be the upper Midwest. Now, here's a little bit of a preview as to what we're talking about. That's a nice area of low pressure there, too. So let's back this up here. We'll go back to the 30th here, Wednesday morning on Halloween. So again, our perfect storm is ongoing back over here. All right, high waves, huge seas, hurricane force winds across parts of the North Atlantic. Again, the Andrea Gale was up around this entire area. It was actually en route back from the Flemish Cap, which is over here. And again, it was trying to get back to the Massachusetts coastline. So again, that's what's going on. There's that high pressure blocking this. That high pressure also caused another traffic jam. So not only did that high pressure cause a traffic jam for what ended up being the perfect storm, but it also caused a traffic jam that backed up across much of the United States. In weather, folks, everything is connected. And this was a heck of a connection, because that high did not want to move, and that made things very interesting. Let's go ahead here and take a little bit of a look at the upper level charts on the morning of the 28th. Take a look here. Now, we have our whole perfect storm thing here happening off the East Coast here, but because that high pressure's in the way, we got this ridge, upper level ridge that you can see extends here to the Ontario-Quebec border. All right. There we go. We got a blockage already. We got another upper level system coming out of the Rockies that can't move because that thing's in the way, and that high pressure doesn't feel like moving. So this created a very interesting setup where suddenly we are now seeing another strong temperature contrast beginning to develop across the central part of the United States. Not only that, but the way this thing is set up is now we have quite a bit of moisture coming out from the Gulf, making its way almost straight northwards into, the parts of the upper Midwest. So we have another setup for a really good area of low pressure. And that's exactly what began to happen as we moved our way forward. So there's that frontal boundary. You can see it struggling to move. It can't move. That high pressure's in the way. And you know what I mean? It's just causing this traffic jam. Look at this high pressure back here across the Dakotas. Now, this in itself, folks, was an unusually cold air mass. Some daily record lows were actually set across parts of North Dakota during this time. We're talking temperatures in the single digits. Now, to put it into perspective, temperatures have been running pretty warm across parts of the upper Midwest ahead of all of this here. So not only are we talking about, strong frontal boundary, but it's a strong frontal boundary that also eventually did bring some record lows in some areas. So let's go ahead and advance this forward here. Let's go ahead and we'll advance a day ahead to Halloween itself. All right, so we got our high pressure up here, and now we got our high pressure from North Dakota had nowhere to go except up north. All right, that was how the upper levels were situated. Okay, this thing had nowhere to go except, kind of following the way the upper level wind flow was. So now we got this area of high pressure began to kind of vacate the upper Midwest, and we have ourselves a pretty defined upper level system that triggers off a new area of low pressure across parts of, around the Ozark area. This low pressure, being a low pressure, didn't really have anywhere to go because, again, we had this whole traffic jam. We have this whole traffic jam thing going on here. That low pressure's got no choice but to go straight north. And that's exactly what this dude did. Let's advance it forward here as we move our way through the day on Halloween, 1991. You can see that low getting organized down across the deep south. And there's that frontal boundary trying to advance a little bit. But overall, that low pressure latches right on over southwestern Missouri. And you can see how it begins to deepen. It begins to intensify. It's got a lot of warm moisture to work with down to the south. It's got a beautiful temperature gradient. And it's got nowhere to go but north because there's things blocking its way here. And take a look at this thing. Not only that, but then we got kind of this little secondary area of low pressure that decides it wants to, quickly join in, kind of an extra push of cooler air from, again, yet another area of high pressure back out. So, again, folks, this was a weather traffic jam. Okay, this was like, Chicago style gridlock, of weather map. Just keep adding semi trucks to it, and that's effectively what was happening here. So now we got this area of low pressure, this little secondary one right here. It's about to meet up with this main area of low pressure, and take a look at what this thing becomes by the time we get towards Friday morning on November 1st. That is a full-fledged blizzard and ice storm across Minnesota and parts of Wisconsin. Now, while this area of low pressure is not as strong as obviously the perfect storm, this is still a decent area of low pressure, and it produced record snowfalls in some parts of the upper Midwest in the order of not inches, but in feet. All right. So, again, the movie focuses on the New England portion. While that's happening, we got a blizzard ongoing across parts of the upper Midwest. So, let's take a look, folks, at some of those snowfall totals. Here's the track of that low pressure. We can see it go straight up toward the north, goes right through central Wisconsin. It reaches its peak intensity going into early November 2nd. That is a very strong low pressure, 984 millibars. All right. That's a pretty decent low pressure. Not the strongest extratropical low pressure that we've had, but that's certainly one. And with everything else going on, it was enough to get the job done. You want to see the snowfall totals across Minnesota? There you go. About 32 inches of snow in some parts around the Duluth area, heading back up into Cook and Lake County, the boundary waters and the Canadian waters. Look at that. All right, we're talking over 20 inches of snow in Minneapolis. Not only that, but as mentioned, across parts of Iowa and southern Minnesota, it was also an ice storm. So there you go. And you can see how tight that snowfall gradient was. So that, folks, is the perfect storm in a nutshell. It was not just perfect of a storm for the East Coast, but it was also a pretty perfect storm for the upper Midwest. You could argue, though, and you can make the argument that the perfect storm of the New England was a separate storm from the one that happened in Minnesota. And if we're talking about low pressures, yes, that is correct. But if we want to talk about cause and effect, the blizzard, the Minnesota, the Halloween blizzard of 1991 across Minnesota was a direct result of the perfect storm off the East Coast. Both of those were a direct result of this high pressure that did not want to move. So pretty cool there. Like I said, folks, in weather, now we just glanced over a lot of the stuff here, folks. There is so much more to uncover with this weather event. But that's just kind of a simple, explanation of what happened. So when you do watch the movie The Perfect Storm, and I think one of these days what we're going to do is we'll get some scenes from this movie, telling you all now to watch it now, because, we do it again, we might have to give away some plot points, but I think it'll be very interesting to go through some scenes of this movie as well as in the book and kind of show you what it was depicting, what was happening in real world with the weather in this movie. Like I said, my sisters always jokingly called this movie The Perfect Snore. It does have a lot of dialogue in it, but I do think that the storm portion of the film was very well done. The CGI, like I said, for this being 23 years old, the CGI is fantastic. And what's interesting, if you want to get into a CGI conversation, is how the movie Twister only came out, 4 years before the movie The Perfect Storm, and there's such a difference in the quality of the CGI. Now, that being said, this was CGI, waves. This was CGI tornadoes. I'm not really much of a CGI expert, but I do believe tornadoes might be a little bit harder to CG there. But certainly a great weather movie if you like it. This movie also got me interested in, ship story, ocean, Coast Guard rescue stuff, that kind of stuff and everything. And so, like I said, of all the weather movies that were around when I was a kid, The Perfect Storm was probably Like I said, Twister may have had something to do with my obsession with weather, but again, this movie came out when I was, what, 3? So I don't really remember much about when I was 3, but I do remember watching this movie pretty much daily up until the movie The Perfect Storm came out, and then I was pretty much watching this almost daily. Ask anyone in the family. I know most of the lines from both movies. Literally, most of the lines from both movies. So yeah, good movie. Like I said, we want to talk about weather movies. That's a good one to discuss there. So, like I said, we'll revisit it at some point. In the future. I think it would, like I said, be kind of fun to walk you through some of the scenes, and then maybe we could do the same thing with Twister. Albeit, I will say Twister is very meteorologically inaccurate in a lot of ways. But hey, it's really the only good Treno movie we got. So rock on. And it is a staple of the '90s, folks. Twister is when it comes to what movies, Twister is a good staple of the '90s. Let's be real. So yeah, that's that. So again, we went through a lot here, folks. Like I said, that's just kind of a quick explanation. If you want to do more reading about it, certainly it's an interesting one to read about the effects and everything that happened during that event. Like I said, it's noted, especially for just the intensity of the system. Even though, like I said, the impacts, well, felt somewhat inland, not as much as what happened over the ocean, and that's kind of what makes it also easy to kind of forget. It's not like Sandy. Wow, Superstorm Sandy back in 2012 that ended up flooding half of New York City. Of course, then again, New York City is not exactly the highest elevation, and it's right on an ocean, but it has a lot of subways. That's not the point. The point is that the perfect storm, a lot of the strong effects of it were mainly tied to the coastlines. And so that's kind of why it may be forgotten more so than other systems. And obviously, but that whole thing, the whole East Coast thing, completely overshadowed the blizzard part that was happening in Minnesota. So again, lots to unpack with that storm. All right, folks, I got to change into my Halloween costume because I got to get ready to hand out candy. I'm curious to see how many kids will show up. It's about 30 degrees. We have about 2.5 inches of snow on the ground, and it's a little bit breezy, and the sky's clearing out actually. So we're probably going to see our temperatures dropping into the teens overnight tonight. So it'll be interesting to see who all shows up. The less kids that show up, the more candy I get. Excellent. So with that in mind, everyone, I hope you all have a good rest of your Halloween. We'll see you back here for tomorrow's weather chat. Who knows what we'll talk about? Maybe we'll take a look at snowfall totals. Have a good evening, everyone.